In this third example, we are doing confidence interval estimates for proportions. And in this particular problem, we are given that a university planner wants to estimate or determine, the proportion of spring semester students who will attend summer school. She surveys 32 students and discovers that 12 will return for summer school, and then we're asked to construct a 90% confidence interval and of all the current spring students who will return for summer school. Now, first of all, I want to point out some parallels between the proportion confidence interval formula and the confidence interval formulas we've been using. In the past, we had for both the z-value and t-value formulas, we had x bar here, plus or minus, and when we had large samples, we had z of alpha sub alpha divided by 2, or for the t's, we had t sub alpha divided by 2. And then we multiplied that by the standard error of the mean, which was the standard deviation divided by the square root of n, and for t's it was s divided by the square root of n. The point simply is that our formula for proportion is in the same thing, in the same format. We take the proportion for the sample, we multiply a z-value that is associated with our confidence level times a standard error. Now, for proportions, the standard error of the proportion is given by this formula, which we have also used back in Chapter 7. So everything is pretty much the same. It's just that we have to know that the standard error is given by this formula, the p times 1 minus p divided by n square rooted. And that really is the only difference. Now, I do want to point out this as we move into Chapter 9, out of 8 and into 9, anytime we have proportion problems, we will always use the z-values. We never use t-scores with proportions. It's always going to be z's. So that's just a little point that might be helpful somewhere down the road. Now, I'm going to take this out because it's not necessary for our work, and we will continue on with the problem. Part A says construct a 90% confidence interval estimate for the portion of current spring students who will return for summer school. So for Part A, we want to take in a little information. First of all, our P is going to be the 12 students who said they will be returning divided by the 32 students who are polled. 12 divided by 32 is, if I am calculating correctly, 3 over 8, which is 0.375. And we'll definitely need a calculator for this problem in the end. Yes. Now, that is our P. So therefore, our 1 minus P is 1 minus 0.375, which is 0.625. So when we calculate our standard error of the proportion, it's going to be the square root of 0.375 times 0.625 divided by n is 32. So the standard error of the proportion is and then of course we have to square root that value. 0.0856. I have my software crashed in the middle of this problem, and so I've lost some of my work, but I can repeat what we had found. We found that that P was equal to 12 over 32, which is 3 over 8, which is 0.375. And then we found that 1 minus P was the 1 minus 0.375, which is 0.625. We put all of these values into our formula, noticing also that n was 16, but we put all of these values into our formula and found that our standard error of the proportion was 0.0856. And of course, this was the 0.375 times 0.625 over 16. Oh, excuse me, not 16, it was 32. And that is about where we were when the software decided to shut down. Now, for a 90% confidence interval on a z-score, then we can just go back to the z-scores that we already know for the 90% confidence interval. And this is why I had suggested making some sort of a table where you well, that's not useful. Where you can refer back to when needed. You don't want to have to look those areas up more than one time. And so we have them right here. For a 90% confidence, it is the z-score associated with that is 1.645. So now we're going to use the proportion formula over here to the left. The proportion that we found as the sample proportion was 0.375. And we are going to take the z-score we found, which is the 1.645, and multiply that by the standard error of the proportion, which was the 0.0856. And it is 0.141. I think that would be an excellent rounding. So we take the 0.375, subtract the 0.141, and we can also add it. And we have our interval. So the answer for A is 0.234 to 0.516. For part B of our problem, we are asked to find the n value that will provide a margin of error of 3% or less, and on this proportion problem. Now, we are going to be changing the confidence level. In this case, it's 0.95, which is the same thing as a 95% confidence level. And of course, if we go back to the chart that we created earlier on the first example problem, we find that the z-score associated with a 95% confidence is 1.96. So our n is going to be the 1.96 squared times p, which was, we found earlier, 0.375, times 1 minus p, which was the 0.625. And of course, all of this will be over our error, our acceptable margin of error, which we are calculating to be at 3%. That's 0.03 squared. And we simply would need our calculator. And we divide by the 0.03 squared, which is 0.0009. And we find that it is 1000.417. The textbook gives this answer to be 1001. And the question may be, why did we round a 1000.4 up to 1001? And here is the reason. If we want to ensure a 3% or less margin of error, then we would have to have at least 1000.4 students that we polled. And since we can't have 4/10 of a student, then we have to go across that 1000.4 or beyond it to the 1001st student. If we only polled 1,000 students, then the margin of error would be slightly more than 3%. So the moral of this story is, if there's a decimal at all when calculating the n, then you have to go ahead to the first whole number beyond that decimal. So the 1000.417 would round to or jump to 1001. This will begin our fourth type of example problem. This is a problem where we are asked to find the sample size that will ensure a given margin of error. The formula that we use for this type of problem is here in the upper right hand corner of the page. These problems are pretty straightforward. You'll simply need a calculator to calculate the answer, but here we see that we have to have a z-value which we're going to square. The z-value is the one that's associated with a 95% confidence interval, and so if we go back to those z-scores that we recorded earlier for different levels of confidence, we see that the 95% confidence level is represented with a z-value of 1.96. So we'll use z 1.96. Then we have, we know that our coal tonnage has a standard deviation of 200 tons. And we are asked how many days should we sample, so N represents the number of days, and of course that's what we're looking for, so that the margin of error will be 39.2 or less. So margin of error 39.2 or less. So we're simply going to substitute these values into this formula. N will be equal to the 1.96 squared. The standard deviation is 200, and we will divide by 39.2 squared. And on our calculator, we'll simply calculate. And we have a numerator of 153,664. The 39.2 squared is an even nicer. This is going to be a lovely calculation. And so when we divide the numerator by our last answer, we get 100. So the answer is that they should sample for 100 days. And that will ensure that their margin of error is 39.2 or less.